Okay, you're given a piecewise function, f of x, where the rule when x is less than 0 is this rational function. And when x is greater than or equal to 0, you're given this rule, cosine of x plus a, and we want to determine the value of a that will make f of x continuous. Okay, so this graph kind of gives us an idea of what's happening. To the left of 0, we have a rational function that looks like this. It's got two branches. There's a vertical asymptote at x equals -6, and we'll talk about that in a minute. The problem is that we have a jump discontinuity right here where I have a equal to -1/7. Just to give you an idea of what's going on, we'll go to Desmos and I'll use the slider on a to show you that as a changes, that function rises. So we have to find the value of a that will what this on the pushing closer to 0. It looks like it might be -0.7, but it actually isn't. We want to find the exact value. So what is this y value? What's the limit from the left of 0 as x gets closer and closer to 0? Well, you can see that this is the same as I factor out an x or divide by x. Now, I won't be dividing by 0 if I do the direct substitution. I'll just get 1/3. And that's what we want this function to equal when x equals 0. That will move this part of the graph and fill in that hole, actually. So we want the cosine of 0 plus a to give us a value of 1/3. Again, so that this branch will kind of slide up to there, and we'll have the limit from the left equal the limit from the right, and the function will also be defined at x equals 0. Okay, so we know the cosine of 0 is 1. 1 plus a equals 1/3. So a has to equal 1/3 minus 1, or -2/3. And by the way, this table shows us getting closer and closer to 0 from the left. And you can see we're getting closer and closer to 1/3. So if I go back to Desmos and change a to -2/3, whoops, 2/3. Now it looks like this limit from the left, which is 1/3, equals the function value at x equals 0. So this hole is no longer a hole. There you go. Hope that helped. If you have any questions, post a comment.